Alright guys, as a follow-up to the long division we did last time, which was an essential skill for advanced functions and calculus for Ontario high schools, today we're going to take a look at a more advanced case of long division. More specifically, we're dealing with the case, what if they are missing or skipped degrees, right? What do I mean by that? So take a look at my dividend, this number on the top. I have x to the degree, x to the power of 4, x to the power of 3, x to the power of 1, and x to the power of 0, which is the constant, right? And I'm missing an x to the power of 2. And if you look at my bottom, which is the divisor, I have a second degree function, right? 2x to the power of 2. And if this were a full polynomial, I should have an x to the power of 1 term, but I'm missing that. So when you're dealing with skipped degrees, what do you do it exactly? Well, actually, the idea is that you got to give it a placeholder. So let's demonstrate this through an example, right? So as usual, let's write down the sign for long division, right? Which is we put the dividend on the inside, 8x to the power 4 minus 10x to the power 3. And if you really want, you could put an 0x to the power of 2, right? Just a x squared term with the coefficient of a 0. Then you put the 6x to the power of 1, then minus 3, right? Then you can do the same thing for your divisor. 2x to the power of 2 plus 0x minus 1, right? Now we just do the same thing as we did last time. Let's try to satisfy the highest degree term first, which is 8x to the power of 4. I have to multiply the divisor by an 4x to the power of 2, right? Because 4x to the power of 2 times 2x to the power of 2, this will give me an 8x to the power of 4, right? So let's do that. That should give me 8x to the power of 4 as a leading term. Then 4x squared times 0x, this is actually 0x cubed, right? So it's just 0, I'm going to leave it blank. Then 4x squared times negative 1, this is actually negative 4x squared. Do my remainder, negative 10x cubed still remains, right? Because it's blank below that. Then 0 minus negative 4, this part, right? So remember, it's minus and negative, so it's actually positive 4x squared in the end, right? Now let's bring it on the next term, positive 6x, right? Then I just do the same thing. I'm going to try to satisfy my highest degree term only. So in this case, I need to give it a quotient of negative 5x, right? Because negative 5x times 2x squared will give me a negative 10x cubed, right? Negative 5x times 0x will give me 0, of course. And then negative 5x times negative 1 would give me a positive 5x. So if I do the remainder here, it would give me a 4x squared plus 1x, right? Then bring down the last term, which is a negative 3. Again, I only care about the leading term, right? So I'm going to give it a quotient of 2, positive, because 2 times 2x squared will give me 4x squared, right? 2 times 0x is still 0, right? 2 times negative 1 is negative 2. So my remainder is actually x here, and negative 3 minus negative 2, which is negative 3 plus 2, which is negative 1. This is my remainder, right? And it makes sense, right? If I'm dividing by a second degree, I should have at most a linear remainder. It could be a constant remainder as well. It could have no remainder, but it cannot exceed 2, right? So that means I can rewrite this fraction as 2x squared minus 1, my divisor, multiplied by my quotient, 4x squared minus 5x plus 2, right? Then plus the remainder, which is x minus 1. And of course, divide everything by my divisor, right? Just the denominator. Then, of course, we can rewrite this as 4x squared minus 5x plus 2, then plus x minus 1 over 2x squared minus 1.